fill in the blanks on the exam, but it's always good to answer questions that way. Here's a question, believe it or not, that students quite often miss. What is the direction of tubular secretion?
What is the direction?
Or reabsorption. They're the easiest questions, but some people get them mixed up in their brains, so make sure you don't do that. If the secretion is from blood to filtrate, and if it's reabsorption, it's from filtrate to blood. I'm keeping it. Keep that in mind. And this relates to the diagrams we looked at, what we've just been talking about, of course. That's no big deal. For reproduction, I think there's anything here that's really, we've studied in lab as well as lecture. Sperm structure. Talk about the head with the DNA, and then, you know, how many chromosomes in the head of the sperm? And it's got that cap on it that I don't name it here, but it's got the acrosome, which helps it digest to the egg, of course, helps it tunnel into the egg. And the egg then takes in the first sperm that it contacts, the rest of them are blocked. And the mid piece of the sperm is the powerhouse. That's where the energy comes from for the tail to move. The tail is called the flagellum. Now this is just a statement. Remember the diagram for male physiology? That one that I drew in there, you probably got a much more artistic one in your book, but whichever one works the best for you. I just want you to know that the various steps from hypothalamus, it's the same as in the female from there, gonadotropin releasing hormone, anterior pituitary releases 2 gonadotropins in the male. What are they? Same as in the female, FSH and LH. What does LH target? The little cells that are between the tubules that make testosterone. What do you call them? Interstitial cells, yeah, that's what's targeted at LH. And that then stimulates the testosterone production. And then, of course, the follicle-stimulating hormone, that's going to target your Sertoli cells, also known as nurse cells. And they make this protein that binds testosterone. Remember, most any steroid, if it's going to work within the fluids of your body, needs to bind to a protein. It really is a lipoprotein is what it would be called. And they together then will stimulate spermatogenesis. So that's that line right there. Put the diagram in, but that's the line anyway. The PowerPoint. This is pretty straightforward description of seminal fluid. And semen. The semen is the mixture of seminal fluid and sperm, of course. Why is it that we say that, why would you suspect that less than 20 million sperm per milliliter of semen would be cause sterility, physiological sterility? What would be the reason for that? Remember when those,
50.
where are the sperm deposited in the female tract? Right up at the mouth of the cervix. What they call the external ostium. They kind of coagulate for a while and then liquefy, and the mucin and everything helps those sperms start making their way up the uterine into the uterine cavity. The uterus also produces waves of muscles. There's a chemical in this. I didn't talk about this earlier, but there's a chemical in semen that stimulates the smooth muscles of the uterus to kind of reverse peristalsis, kind of help the sperm. But a lot of those sperm don't make it. They die. They go the wrong way, let's say. There does tend to be a chemical sense that where the egg is, though, with these guys. But still, when you get out into the ampulla where fertilization is to occur, you might have only a few hundred to 1,000 of those sperm left of the couple of hundred or more million that started the trek. That's quite a loss.